For our second application, we have that the function p of x equals 95 minus 30 log base 2 of x models the percentage p of students who could recall the important features of a classroom lecture as a function of time, where x represents the number of days that have elapsed since the lecture was given. And what we want to do is find out how many days it would take for all students to forget all of the important features of the classroom lecture. So we have our function here. It's a weird one, but it's still a function. And we want to find out what amount of time it takes for everybody to forget. That is, we want p of x to equal 0, which implies that what we need to solve is the logarithmic equation 0 equals 95 minus 30 log base 2 of x, or pulling the 30 log base 2 over, 30 log 2 of x equals 95. Then dividing out the 30 to isolate the log 2, we would have log base 2 of x equals, well, 30 over 95 is not that nice. It ends up being 19 over 6. And then from there, we recognize that we're in the logarithmic form where we have a logarithm and a constant. So we just use that exponential flipping to get that x, in this case, would be 2 raised to the power 19 over 6, which is a little bit more than 2 cubed. So this whole thing is going to be a little bit more than 8. And if we want to get an approximate value, we can say that this is about 9, because this is a number of days, and we're not in Kingdom Hearts world here where we can throw in whatever decimal we want as far as days and people will be okay with it. Here we like something more exact. So we would say that after about 9 days, I can expect everyone in my classes to have forgotten everything important from them. So I guess it's a good thing that I have all this recorded. So by next week when you've forgotten all this stuff, you can just watch it again. It's perfect for me, right? Well, that assumes you're watching it now and that you'll watch it again later. Yeah. I guess I'll find out when it comes to the next exam. But that's all we have here for 4.4. For 4.5, we're going to be doing actually a lot more things with applications here. We're going to be doing a lot more applied stuff in the context of exponents and logarithms, looking at things in terms of data modeling, and in particular modeling using what are called exponential growth and decay functions. Let's get in there too.